Let's talk about conjunction. So conjunction is represented by the dot, although of course this varies, right, depending on your professor. Some prefer to use the ampersand, others use the upward caret, right, so there may be a few variations. My preferred usage is the dot. And conjunction just means and, right? So this is the name that we give to the word and in natural language English. So I just want to talk about what the variants are, the ways that you can see conjunctions in natural language, what it is that conjunctions serve to do in natural language. Then I'll offer you up a truth table that shows you how this thing computes things in statement logic, and I'll end by giving you a definition. So let's go ahead and start off with some variants. So there aren't that many. And is, of course, the most popular one, so you will see conjunctions just as and, right? But there are a few others. So for instance, you might see in addition to, furthermore, and so on, right? So just to give some examples, right? I'm angry and I'm hungry, right? What am I expressing? Well, I'm expressing both, right? That I'm angry and I'm expressing that I'm hungry. I can also say I'm angry in addition to being hungry, right? Or I'm angry, furthermore, I'm hungry, right? And in all of those instances, I'm trying to tell you that both of these propositions hold true of me, right? In fact, there may even be a special relationship between those two. Perhaps I'm angry because I'm hungry. Now, in natural language, right, we're very comfortable with this. We're very used to using this language. And what we're expressing with this is that both of the propositions that are being held together by the conjunction are true. That's all we're saying. And in fact, a very easy way to see that is under which conditions we would think that somebody is lying to us, right? So if someone were to say, last night I watched a movie and ate some pizza, and it turns out that last night they did both of those things, then they told you the truth. However, if they failed to do either of those things, even if they did the other, we would consider them lying, right? They would be lying. They would be giving us a falsehood. So if they said, last night I watched a movie and I ate pizza, but it turns out they watched a movie, but there was no pizza, for some bizarre reason, they've decided to lie to you, right? Just as well, if they said that they watched a movie and ate pizza and they ate pizza but watched no movie, that's a lie. If they decided to neither neither eat pizza nor watch a movie, they lied, right? So the conjunction is true only when both of the conjuncts are true. And we can represent this with a truth table. So let's take a truth table where we have P and Q, right, and we want to evaluate P and Q. Now again, as I've said in my other videos on the logical operators, P and Q here are variables, right? So they stand for any well-formed formula. So this truth table will work for any well-formed formulas that are held together by conjunction, right? So it'll grab the truth values of those and compute them as this expresses. So we'll lay out our truth values: true, true, false, false, true, false, true, false, right? And that gives you every single combination of truth values for these two. And then you'll see that the way that this computes is just the way you would expect it to in natural language, right? So if P is true and Q is true, then we know that the person who told us that they were eating pizza and watching a movie told us the truth, right? So that computes out to true. However, if either of these turns out to be false, or even both of them turns out to be false, then this will compute to false, right? So if P is true and Q is false, P and Q will be false. If P is false and Q is true, then the conjunction of P and Q will be false. And if P is false and Q is false, then the conjunction of P and Q will be false. So P and Q is true only when both conjuncts are true, right? And the conjunct is just the fancy word that's given to the components of the conjunction, right? Otherwise, the conjunction turns out to be false. We actually formalize that as a definition, right? So let me write that down. So a conjunction is true if and only if both of its conjuncts are true. Otherwise, it's false. Apologize for the handwriting. The second that I have to crouch a little bit, it gets a little bit harder to write. If only I could have this board be a little bit higher. But this definition captures exactly what this truth table is telling us, right? So a conjunction is true if and only if both of the conjuncts are true, right? So whenever you have these two, that's true. If this is true, you'll know that those two have to be true, right? Otherwise, and this is just for clarification, right? So if anything other than these two things being true happens, then the conjunction turns out to be false. And that's everything that there is to conjunction. I'll see you around.